Bonjour à tous, je suis Noé Bernard de DataScientest et bienvenue dans ce nouveau webinaire. Un webinaire un peu spécial parce qu'il va se dérouler en anglais. En effet, je suis avec Tushar. Hi Tushar, you are a data engineer at Meero.
Yes, hello.
Yes, and today you're gonna present all the open source platform of Airflow. That's it?
Yes, exactly. So I'll present about the introduction of Apache Airflow. I'll also present a use case of how we implemented in Meero. And then I will do a small demo for Airflow, which will be a bit more interesting than a normal presentation.
Okay, thanks. As usual, you can put some question on the chat and Tushar will reply to it. Maybe at the end with the Q&A answer time or during the presentation. Donc feel free to ask Tushar on the chat.
Yeah.
So I'll let you present your subject.
Yes, thank you.
Thanks.
Hello, everyone. So today we will discuss about Apache Airflow. It's an open source platform which is disrupting the data engineering environment currently. So before I start the presentation, I want to do like a quick introduction about myself. So I am working as a data engineer in Meero since September 2019. Before that, I was working in Papernest also as a data engineer. And I also have an experience as a data analyst in Jumia Classifieds. Before we start the big presentation about Airflow and I want to present something about Meero. So Meero is a French scale-up which is in the field of on-demand photography, which was started in 2014. It is a French unicorn and has business all over the world. It covers many sectors like food, real estate, lifestyle, e-commerce, events. We also have a state-of-the AI, which is developed by our R&D, research and development department, which is used to edit photos. So it is a great help when we want to edit photos in a large quantity. We have specialized pipelines, AI pipelines, which can edit the photos, do some basic editing. So for example, you see a picture here, you have the before picture, which is directly sent to us from the photographer. And then we have after photo, which is directly developed by our AI pipeline. We also have a community of photographers. We keep a good community of photographers to keep them engaged, to give them different projects. And yes, so this is in brief what we do in Meero. So how will we go through this presentation? So in the beginning, I will present to you the data stack of Meero. It's a very top view of the data stack. We won't go too much in details about the data stack. Then we'll discuss about a use case of Meero, like what was the problematic. Then we discuss about Airflow, the solution which we implemented. I will present to you the advanced user interface, which is present in Airflow. Then we'll go deep into the concepts. I'll explain to you some core concepts. I will explain to you the architecture, what goes on behind Airflow. Then I will present you a small demo. I prepared a small demo for this presentation, and we'll go through it. And then finally, we'll discuss back the use case and see like how Airflow was able to meet the requirements of Meero. So yes, let's start with the data stack of Meero. So the workflow management, that is, you can say it as a workflow management, or you can call it as a data pipelines. So it is completely on Airflow, on Apache Airflow. It is used for data extraction from different sources. Like we have ton of external sources from which we are extracting data. We are connected to different cloud providers like AWS, Amazon Web Services. We are connected to GCP using directly from the Airflow. We are also refreshing a lot of tables, like we have different tables for different business units, which is also done via Airflow. And we have some data science scripts which are running on Airflow. So the Airflow, it is, as I said, it is connected to AWS and cloud storage. So we are running some scripts of data science scripts on these platforms. So for the data warehouse, we are using Amazon Redshift. It is a big data size warehouse provided by the Amazon Web Services. Then for the data visualization, we are using Looker. And finally, for the cloud, we are on AWS. When I say cloud, so it also contains the service for the data warehouse, which is Redshift, for the data lake, which is the S3 buckets, but also the servers which are running behind Airflow. So those are also hosted on the Amazon Web Services. So yes, let's discuss about the use case before I deep dive into Airflow and start explaining you all the things. So basically, Meero went through hyperscaling and the data requirements exploded. There were multiple data sources which were needed to be extracted, transformed, and loaded. The data was coming from a lot of places. We had multiple external data sources from which we were extracting data. Then there was data from the platform, the photographers' data, the shooting data, and all these data. And the huge amount of data was required in the data warehouse on a daily basis. Then for different departments and business units, which were spread over multiple countries, we wanted complete and refreshed data over a regular period of time. Sometimes it could be daily, sometimes could be a little bit more frequent, like every few hours. And for doing this, we had to extract data from multiple sources, like from APIs, from files, from databases, and everything. Then we have to clean and transform all this data, joining this data with other data sources, and then send it to data analyst and data scientists so they can do their magic. But before this, all the cleaning, transforming, extraction was on the data engineering side, and this was a issue for us because the hyperscaling we went through. So in short, it was hundreds of tables which were required to be refreshed daily, sometimes more frequently. We had 50 plus, right now more than 70 data pipelines which are ETL, like extraction, transforming, and loading, or ELT or EL pipelines. So we have different kinds of pipelines which were running throughout the day. So in short, what we needed, we required a solution or a platform which was open source but heavily maintained and stable. We want it is quite important for it to be an open source in a startup or a scale up environment, because it is free and we can do a lot of things with it. Also, it should be easily customizable and written in Python. When we say the script is easily customizable, that is like it has a rich library, like inbuilt library, but we can also write our own scripts and do things what we want, like not only depend on a pre-packaged software. It should be scalable, robust, and dynamic. Scalable means as the data requirements will grow in the department, the platform should also grow with it. We don't need to wait for it to scale. We can do all these things on our own side. It should be dynamic. Being dynamic is very important for us, because we don't want to write everything. When I say dynamic, it is like repeatable task can be dynamically created during a pipeline. And also it needs to have an advanced UI where we can directly see the logs, task performance, and which is very easy to monitor. So yes, we were looking for a lot of requirements, and we were looking for a solution which can provide all these answers to us. So for this, we implemented Airflow. So going through the definition of Airflow, it is an open source project which can programmatically author, schedule, and monitor workflows. You can basically script what you want. Your data pipeline or your DAGs or your workflows are basically scripts which are running. A bit history: it was started in Airbnb as an open source platform. All the message queues and all the tasks which were running inside Airbnb was done using Apache Airflow, and then it became an open source project. Currently, this project is widely used and maintained, with regular releases done, like every few months there is a new release which is done. And right now there is an active community which is making this project better to use. So few main concepts for Airflow: it is scalable, that is it can scale to infinity. You can do as many, you can improve or scale it as much as you want. It has a modern architecture, and it uses the message queues for worker. So I will explain to you in more detail what are message queues and what are workers in the later slides. Then it is dynamic. So it is, as I told you, it was a requirement for us. So it is written in Python, and it is dynamic in nature. So when we are writing a script, we can pass the parameters, and Airflow can itself create a data pipeline out of it. So that was quite useful for us, because when we have thousands of tasks running, we don't want to script everything. Then it is extensible. That means it has libraries, like when you create or use Apache Airflow, when you download it from Git, there are some libraries which comes in it, but you can always build custom operators. You can build some custom scripts which can do the job for you. And it also maintains abstraction. That is, like, it's we can only see the scripts or the code which you want. We don't need to have the entire details of it. Also, it is elegant. The pipelines, which I will show you later in the demo, they are lean and explicit. The pipelines, it's very easy to see, very easy to maintain. And also you can do parameterization with Ginger templates. So you can parameterize, that is, like, you can add some variables, pass some arguments using the Ginger templates. So I will show you a little bit about the UI. So as I told you before, we were looking for a solution which has advanced UI. So what are the major issues which we see in a platform? One of the major things is, like, when you have a pipeline, you want to have a good view of the pipeline, like what all steps are being done in the pipeline. Else it will be just code, and it can be difficult to, if you have a small team of data engineers, or if you want to introduce more data engineers in the team. If it is just scripts, then it becomes quite complicated. If it is just code, it becomes quite complicated to see, okay, what the data pipeline is doing. So this is Airflow provides a solution in which we can see these pipelines. Then you have the logs. For the logs, do you need to go in the machine, or do you want to go somewhere else to see the logs? Can you directly see the logs directly from the UI? Also, you want to see how the task is performing, like every day, if the task is running, how much time is it taking? Is it always taking the same amount of time, or the time is increasing, decreasing? So these few concepts are very important for a data engineering point of view, and we were able to see all these things on the user interface of Airflow. So quick presentation for the UI. I'll do a tour here, and then when we are in the demo, we'll go more deep into this view. So we start from the top level, which is called as the DAGs. The DAGs is a directed acyclic graph, or in simple terms, you can say it is a data pipeline. So each of thing which you see here is actually a DAG. All of them are different data pipelines in the web server, which you will, or the UI which you can see. Then you have the owner of this pipeline. So right now the owner is a default Airflow, but for example, let's say you have 10 different departments and there are 10 different data engineers. So you can put the name of the owners, and each owner can or each department can have their own pipelines. Then you have the runs, which says, okay, how many times this pipeline is running or has run in the past. Then you have the schedule. You can easily schedule them. You can say, okay, you run once a day, or you run 10 times a day, or you just run once. So it's very easy, and you can see directly on the main platform. You can see via the UI the schedule of it. Similarly, you have the last run, you have the recent tasks, which gives a lot of information on the first view. So when you have, let's say, 100 pipelines, you can quickly see which pipelines are running, which have failed, which are waiting. And then there are also some actions you can do. You can click on the start button, and instead of waiting for a schedule, you can just directly execute it. You can delete it and everything. Then these are some more views. When you click inside a DAG, you enter the different properties of a tag. You have the tree view, graph view, task duration, and everything. So some quick things which you can see and quite interesting. So first of all, you have a tree view in which you can see all the tasks which are running, and you can see the history of all these tasks. You can see, like, okay, on this day, all the tasks succeeded. On a certain day, some tasks failed. Some tasks are running. So this is a good view and quite useful for data engineering point of view. Then you have also the graph view. So graph view, it's more like This is the view which I was talking about. So right now the script has converted itself into a graph, and you can easily see like, okay, this task is running first and then this task will run. So there is a dependence or a dependence graph which you can see. You can think of it as a Lego. So each of them is like a Lego block, and you can connect different Lego blocks to create a data pipeline for yourself or a DAG for yourself. You also have the Gantt chart. So Gantt chart is quite useful. You can see like the dependencies or how much time each task is taking to run. For example, if there is a lot of time between them, so you can say, okay, the task is waiting or is in the queue or is being scheduled, but it is not running. So this could also be used to monitoring your infra and to improve the infra to reduce the wait time between two different tasks. Then there is the task duration. Right now it's not very interesting. As you see, like in the beginning it was 0.12 seconds, but later it reduced. But for example, when we have a lot of tasks running and running on a regular interval, you can see the evolution of the task and the time it is taking to run. So yes, now let's discuss some more. Let's go deep inside Airflow and let's discuss some core concepts. I think like, yes, for the questions, we will go in the end, or if you have any questions in between, you can ask me. So yes, let's start with the core concepts. So for the core concepts, we'll discuss 6 main concepts. We'll start with the DAG, or called as directed acyclic graph. Then you have the tasks. Then we'll discuss about the operators. We'll discuss about connections, branching, and Subdag. So the view you see here, it's a live instance of Airflow. The earlier there were some examples, but this is a live instance. I have hidden them to keep them a bit private, but here you have a better schedule. So for example, this will run only once. This will run only on Monday at 5:45. You have the owner, you have the task. This DAG is running, let's say, 4,000 times, and you have the different links. So this is a real life view of the Airflow. So yes, for the core concepts, let's deep dive into them. So let's start with DAG. So DAG in the full form of a DAG is a directed acyclic graph. What it means, it starts from somewhere and ends somewhere. There is not a loop. It has, there cannot be a loop. That is the definition of a directed acyclic graph. So for example, there is this task running, then there will be a branch, and then there will be other tasks running. So if we take the definition of a DAG, it is a collection of all the tasks, basically all the tasks which you want to run, organized in a way. You can create a dependence which reflects the relationship and dependencies. So for example, this task will never run before all this task has run. And a DAG is defined in a Python script. So this is basically a Python script which is converted into this view using Airflow by the Airflow platform. And a DAG run is an instance of DAG containing task instances which is running on a particular date. So for example, this DAG or like any pipeline can run on different dates depending on the execution date. So this is in brief what a DAG is. Then we go inside our tasks. So our task defines a unit of work within a DAG. It is represented as a node in the DAG graph, and it is written in Python. So this complete is a DAG, but one part of it is a task, and it is also written in Python. And each implementation of a task is basically an operator. So this operator can be a Python operator, or it can be a bash operator, or it can be some custom operator which you have created for yourself. So for example, let's say if it is a S3 to Redshift operator, then it will copy data from S3 buckets in AWS and will copy them to a Redshift table. And basically you just abstract it. So it becomes a S3 Redshift operator, but in the backend, you have all the scripts which are doing the operation. But in short, all the green boxes which you see here is a task, or you can say instance of an operator. And you can easily define the relationship between these tasks. And for example, there is an upstream connection which you can do, or you can do some other kind of dependence depending on your need. Also, the task goes through various stages from start to completion. So for example, it will start as a no status. because, for example, it is not its time to run, then it will go in the queue, then it will be scheduled. Like when it is in the queue, that means it's time to run, then it can go running. If everything is okay, it will go to success. It will be failed, and it can also be skipped, or if there is a failure and you have some retry, then it can be retried also. So there are a lot of steps which can do, and the best thing is like you can see all of them directly from the UI. You don't need to go to a container or to SSH to something or see a script to see, okay, this is running, this is not running. Everything will be directly available from the UI. Next, we can discuss about operators. This one is a bit theoretical, but it is an important concept to know. So while DAG describes how to run a workflow, operator determines what actually gets done by a task. So DAG, you can say, is a combination of operators. The important thing is operators are always atomic. So usually they are atomic. The best practice is to make them atomic. So what do you mean by atomic? So when I say atomic, it means that it can run on its own. It does not need any dependence, like all the resources, all or the data which it needs is directly present in the same operator. This concept is linked to parallel processing. So for example, when we talk about Airflow, or there is always parallel processing involved, because there are like different machines which are running different tasks. So let's say one operator or one task is running on one machine and the other task is running on another machine. So if they are atomic, then they can run independently. But if there is some kind of dependence, then it becomes a bit more complicated to run them, because then one machine on a cloud has to talk with another machine on the cloud. So always the best practice is to make a task or an operator as independent and as possible. The DAG, it will always make sure that the operators will run in the correct order. That is the responsibility of the DAG. You will just give the order in which they want to run, but to make them run in the right order, that will be the responsibility of the DAG. It will schedule it in certain order that it will meet the exact requirements. Also, if it is not possible for you to have operator as atomic, then there is a concept called as XComs, but it is a bit more detailed, so we'll not go through it. But it is possible to share information between different DAGs, different operators. Sorry. So here is like some operators which I put. So a lot of them are inbuilt, which comes with the default Airflow installation. But if you want to have more DAGs, then you can simply build them, or you can download some libraries if it already exists. So as I told you, there are like a lot of active development going on behind Airflow. So a lot of operators are already developed. You don't even need to develop them. But if you require, there are always custom things which you can do. Connections, it is quick. So directly from the admin, you can create a connection to our database, to some AWS service, like some big data service, or to GCP or BigQuery service. You can directly do the connection using the admin from the Airflow. It is also possible to create different branches for a pipeline. For a workflow to branch, you can use the branch Python operator. So it's also a concept inside Airflow which is available. And depending on certain condition, either it can run one branch or it can run another branch. So this is also possible directly inside Airflow. Then there is this one of the most important concepts, which is called as subdags. So subdag is like it's perfect for repeating patterns. It is where the parallel processing comes into play. So for example, if there are a lot of repeating patterns, so for example, all these, let's take an example. Okay, this is a DAG, and all these tasks, they are repeating things. So we don't need to put them directly in the DAG. This will become a bit complicated. Here it is only 5, but imagine there are 1,000 processes in both of them. So instead of creating them as a DAG, it can become like a subdag. You can modify your pipeline to look something like this. So each section becomes a subdag which has the parallel processes which can run at the time. So this is an important concept of Subdag, and we'll see this in more detail when we will do the demo. It will be a bit more interesting then. Let's quickly go through the architecture. We have discussed about the core concepts, we discussed about the UI, but the architecture is what basically goes behind Airflow, what is Airflow created of. So here I'm a data engineer. So I am responsible for writing the data pipelines, all the data pipelines which will be running on the Airflow. It will be managed by a data engineer. Also, we are responsible for writing the configuration file. Airflow.cfg is the configuration file which will basically maintain the Airflow, which will decide, okay, how many tasks can run in parallel or how many pipelines can run. Then there are different parts of it. So user interface and web server, we just saw. So the beautiful UI which we just saw. Then there is a scheduler. We go in more detail for this one. The scheduler, in short, it is just looking at the DAGs and seeing, okay, what task has to be scheduled next, what is running, what has to run next, and what does not need to run next. There is a metadata database. It contains all the metadata about the Airflow, like all the information about the DAGs, about the tasks, the operators, and everything. It will be stored in a Postgre database. Then we have some executors, which can be parallel or sequential. And then we have the workers. The workers are actually the machines which are doing the job, which are running the tasks. And they can be a single worker or they can be hundreds of workers, depending on your configuration. Let's quickly see these concepts. So let's start with the metadata database. So this is one of the most important things. It is a SQL database which stores basically all the metadata about the pipelines which are being executed. So for example, you have the information about the tags. You have like which tag is running, what connection we have. You also have all the information about the tasks. You have like which task will be running, which has to be scheduled, which is failed. You have the information about the users, what all user have access to Airflow. You have information about XCOM. So basically all the information which you will see on the UI or which Airflow is using will be stored in this metadata database. So popularly we use Postgre for Airflow. Postgre technology is best for the Airflow metadatabase, but you can also use MySQL. And this database is quite useful when we want to do auto scaling. So auto scaling is a concept in which you can scale the number of workers, increase the number of machines which are running the tasks or reduce them depending on the workload. So for example, in 1 minute, if you need to run 100 queries or 100 tables you need to refresh, you can create 100 workers. And when you don't need them, you can reduce them to just 1 or 2 depending on your need. And this will be done with this metadata database. The web server we already discussed, so it's the UI you see. Then we also have a scheduler, which basically monitors all the tasks and DAGs and then triggers the task instance once the dependencies are complete. So it will basically go through each tag and see if it's time to run that DAG or that task. And if it is there, then it will schedule it to be run the next time or in some other time. It is a persistent service, so that means it will always be running. It will not be stopped or it won't wait for something. It will always go on running, and you can always monitor its heartbeat. It's like how many seconds it will recheck everything. So in the configuration file, you can monitor the heartbeat of the scheduler, or you can configure the heartbeat of the scheduler. Yes, so here is the workers which I was talking about since some time. So the view of the workers you can see on Flower. So this is also a concept, but let's to be easy, it's like all these things you see: salary. So these are all the workers which are present. The offline workers are like which we are not using any at this time, and the online are which are still running. Each of them can have the tasks which are running. This task has processed, how many succeeded, how many failed. So all of this is also available using a UI, and you can increase or decrease the number of workers depending on your need. You can also define how many tasks or how many operators will run on each machine. So for example, you have a simple task, let's say you want to extract some data from the API, and it takes like 100 MB of your memory, then you can, and one of your machine is like 1 GB, you can put like 7 or 8 of these tasks. You don't want to fill everything up, but you can put like 7 or 8 of these tasks to run in the time. But for example, if there's one data science script, or if there is something heavy which will take like 1 GB or 2 GB of your memory, then you don't need to, then you can just put like one task on one worker. It's a bit complicated topic, but this is an important concept when we are dealing with Airflow. So yes, we have done the theoretical part of it. Now we can go through a little bit, like we can spend a little bit time on the demo. So here it is, instance of Airflow. I created the instance of Airflow before the webinar, so we will have something to look at. So as I told you before, this is the UI, the main web server which is running, and we have some DAGs. So for example, there is example DAG, there is another example DAG, and you have the schedule. So for example, this one is running every 4 minutes, this one is running every 7 minutes. I created myself as the owners. Then you have some recent tasks. So for example, 10 tasks has recently run, 10 of them are success, one is currently queued, one is waiting. Then you have the information about the last run. Then you have the DAG run. So for example, this one has executed 47 times, this has executed 25 times. And then you have some other information also. So let's go through quickly through this one, and then we will go inside a DAG and see a bit more. So yes, I told you about the connection. So in the admin panel, you have the connections. Okay, so yes, so you have the connection, you have the connection ID, you have the connection type, the type of host is encrypted, is extra encrypted. So right now I did not created any connection in it. This is like the default connections, but I can show you, like you can basically save all the information directly here, and your Airflow will be connected to that data source. Except that you have a user, so you can create the user. So all the people who are basically have access to this platform will be able to will have a list, and you can create them as super user, or you can give them some rights or something depending on you. Then you have the task instances, like how many tasks are running and everything. But I think let's go through a DAG. That will be more interesting. So let's go through this one, example DAG. So the first view which we see is the default view. This is the tree view which we see. To understand it better, this one is the graph view. So right now this DAG is running. You can always refresh it and see, okay, how much it is running. Or you can go back in the history, and you can see like what was the state of this DAG at certain point in time. So for example, this DAG has multiple tasks, and then this runs after all these tasks has finished. Then you have some other information, and when you click on a DAG, like just put your cursor on it, you have more information about it, like what kind of operator it is, when it was started, when it ended, what is the duration, and all these details. So it is quite useful from the data engineering point of view. Then also you have the log, which you can directly see from here. So when you click on the task, it will give you this information. You can click on the log, and it will give you the information about the log. So for example, this one is just saying hello world from Python. So very simple task, but you can always have any information which you want. So also there is log by attempt. So for example, if it is failing and you have put some retries, so for each attempt it will create another log file, and you can store this log file anywhere you want. You can have a database in which you can put all these logs, or you can put all this in S3 bucket or cloud storage, whatever is best for you. So this is the graph view. Then yeah, if you can always change the view of the graph also. So if right now the data pipeline is simple, but when it is complicated, you can change the data of the view, and it will be better for you. Then you have the task duration. So this is what I told you before. So right now this is how this pipeline has been performing. It was running okay, but then there is suddenly a graph, you can always click on it to just highlight one of the tasks. So this task has been taking 27 seconds, but now it is taking around 7 seconds. This is something quite useful when you have a lot of tasks running and you want to see which task is taking more time or which is taking less time. So this is a good graph which you can directly see from the UI. Also, we have the Gantt chart. So Gantt chart tells us how much time it also took, if there was gap between the two tasks. At this time it was scheduled or it was in another stage. Then also you have the view of the code. I did not went inside the code, but we also have the UI, the view of the code directly from the web server. So this is the Python script, which is basically has been transformed in Airflow to a DAG. So in the end, you can see here, it's where we create the dependencies. We say after all these tasks are succeeded, run this task, then run this task, then do other tasks. So this is quite useful. You can basically schedule it directly on top. You can also improve. Increase the number of retries. Right now it is just one, but for example, if it is critical operation, you can make it 7 retries, 5 retries, whatever is interesting for you. So this is a simple DAG which we discussed in the beginning, and then there is one more DAG which I wanted to show you. This is a DAG with a subdag. So subdag, as I told you before, is let's say it's like a combination of tasks which are repeated at the same time. So for example, you can click here and you can go inside, and basically all these tasks are the ones which are independent of anything, and they can run in parallel. So right now there are only 3 tasks, but you can imagine there are 100 of tasks which are independent and don't need any dependence. So for example, all these can run atomically and they can be put inside a subdag. So one script can have as many subdags as you want. So for them also, it's the same thing. I'll for the question I will discuss in the end. So yes, in the beginning, so this is what Airflow is. Then let's go back to the use case of Meero. So that was the demo. Going back to the use case of Meero, I explained to you the requirements which were needed in the data department, and Airflow was basically able to meet all of them. When I say it is scalable, so right now all the pipelines which we have in Meero are running on Airflow. So it involves extracting data from multiple sources, refreshing hundreds of tables, and most importantly, providing business data on time. So we are able to do this using the Airflow platform. We can control the number of pipelines which are running. We can control the parallelism. They are dynamic in nature, so we are able to create thousands of tasks without defining them individually. So this is quite useful for us. Then it is extensible. So we have used the existing code which was present in the library, but except that we were also able to develop our own tasks or operators and use to do the operation for us. It is elegant. So you can see I have shown you the pipelines which are quite clean and lean. So the graphical interface is developed directly. It is automatically developed by the Airflow web server. You don't need to do a lot of things. You just have to define the scripts behind it and put the dependencies, and it is quite modifiable and manageable. It is quite into idempotency. It follows idempotency. So for example, if you want to run the task in the pipeline at any time, like you want to just refresh a part of the pipeline, so that can also be done. So that is quite useful. So for example, we have a failure in first part of the pipeline, or we did a modification in the first half of the pipeline and we want to refresh the rest of it. So we can start the pipeline at any point and it will execute the rest of the tasks. and it is quite deployable. So Airflow, it is available on Docker. So I'm sure you are quite familiar with the concept of Docker, and with the use of Docker, it becomes quite easy to share and deploy. And it is one of the features which makes Airflow quite usable. So yes, in brief, yes, this is the presentation which I have for Airflow, and thank you for it. Thank you for your time. And yes, I will take your questions if you have any.
Thanks a lot, Tushar. It was really interesting. So we have a few questions on the chat and on the questions tab. I don't know if you see them.
Yeah.
Anna Chefner.
Yes. Okay. So yes, what is your motivation as a data engineer? What gives you satisfaction? How do you consider your job is done? What made you choose data engineering instead of data scientist, machine learning engineer? Okay. What is the motivation as a data engineer? So for me, I'm quite interested in development. So data engineer, it's a concept. It's not only one tool or one technology which you can have and you will be able to meet all the requirements. The environment of data engineering is modifying all the time. You have new tools and new technologies which are coming, and that is quite interesting for me. And this field is ever growing. Like we had like legacy data, which is like just like small databases or data warehouse, but now we have the big data. Like we do a lot of courses and we learn in the school, but the actual development and the actual putting in place of all these data technologies is quite interesting, and that is a reason for me to be a data engineer. How do you consider your job is done? Providing data to the data analyst, meaningful data to a data analyst, and providing meaningful data to the data scientist, so they can meet the business requirements. So that is important. That is what gives meaning to the job. What made you choose data engineering instead of data scientist and machine learning engineering? So data scientist and machine learning is a quite different concept. Data scientist and machine learning, it's more on the models and different machine learning algorithms. And for example, we have our AI pipeline where you are modifying the photos, and it's quite a different concept. And for me, data engineering was more interesting because it was a lot of different technologies to learn. And yes, that was a reason for me.
Okay, thanks. It was a really good question. Thanks, Anat. How do you think machine learning and data engineering at Meero will evolve in the next few years?
So as I told you, like Meero, it is a scale up. So it went through hyperscaling, and we are doing like a lot of processing of data, but still we are in the early stages. Like Meero started in 2014. We developed a lot of things, and the R&D, like we have the R&D pipelines which are editing the photos and which are being improved all the times. So when we integrate more, between R&D and the data services, at that time it will evolve more. It will be more data engineering resources which will be required when we are doing like more real-time data processing. At that time, the data engineering challenges will be evolved. Yes.
Okay, and have you got some advice for a new data engineer who follow our trainings?
Yes, so it's important, first of all, to start from the basics, I will say. So the language, it's very important to have a good about the language, about, for example, if you are in Python or if you are in Java, whatever language you choose. Then you have the core concepts of SQL, but also then you have the concepts about a lot of concepts about batch processing. So for example, when you are moving heavy data at one time, then what technologies you want to use. But if you want to go inside in the streaming side of the data, like you want to use Kafka or you want to use some other technology. And one last thing is, it's very important to know about a cloud provider. Like you need to know about AWS or you need to know about GCP. so that you are, because you don't want everything to be inside with you. You don't need to invest in infra because everything is available on cloud now. So it is quite important to know a cloud service provider.
Okay. Okay, thanks. Just we wait for some questions, but next week we will have Henri Bouxin from GoJob.
Okay.
He will talk about how AI is used to better sharp the recruitment. So stay tuned to have the link. We will send in on the social media, especially LinkedIn. If you want to work in data engineering or things like that, data science or data analysis, I can recommend you to take an appointment with us to discuss with one of our team to have a better idea of what we can do about training. So feel free. I send a link in the chat. Okay, so there are
a few questions. Okay, from Xavier. So is Airflow also used by pipelines, possibly used by data scientists? Yes. So Airflow can be used by everyone. So it is not only for data engineers. So for examples, we have custom pipelines which are for data analysts, and data analysts directly put this tasks, or for example, if it is like a query which is refreshing a table, so data analysts can directly interfere in it. Similar for data scientists. So for example, you don't have a heavy data model, but for example, if you have some data science scripts which is calculating something, so it can be used by data scientists to run their jobs. Airflow is just a workflow management tool, and you can run as many scripts and jobs with it.
Okay, and you have a message from Anat.
As a thank you, as a data scientist, the part is like the least is building the data set for me. It is passionate about it. Okay, thank you.
Okay, new question.
As for Dataiku and Apache Airflow, Dataiku, as I told you, it's like a pre-built solution, and Apache Airflow is an open source platform. So they're quite different. And for example, I have not used Dataiku that much, but it is also where you can build your pipelines. You have data source where you can connect to. But Apache Airflow, you can think of it as like an octopus, with multiple hands, and it can connect to different data sources. So for example, it is extracting data from APIs. I don't think Dataiku will do that. Dataiku is more on the, you have already data in the database, and then you want to do some processes or run some task on top of it. Whereas Airflow, it's more like a tool which can connect to anything. It can run your SQL, it can run your Panda scripts, or it can extract data from APIs, or it can upload data from Salesforce, or do anything. So it's two different concepts, I will say.
Okay, thanks for all, Tushar. It was a really great presentation. I think everybody liked it. This presentation will be able on YouTube for a replay. And I thanks a lot for your presentation, and see you next Monday for the Henri Bouxin webinar.
Thank you.
Bye.
Bye.